Hi, my name is Immaculate Narada, and I'm here to solve a problem using the Parks rule. We all know, just to take you a little bit of what the Parks formula is. The Parks land formula is used to calculate the amount of fluids in milliliters. Don't forget that. That should be given to a patient with burns over the first 24 hours of care. As um, as nurses, we should take note of that as future nurses, that over the first 24 hours, we have to use the PACS formula to um, help us take care of a person of who has burns. So we'll define our variables like this: the the TBSA, which we can say the total body surface area, which is equal to the percentage of total body surface area burned, and then our weight in kilograms. So we calculate using the rule of nines. What is the rule of nine? The rule of nines is when you look at a chart and probably you bisect a person's body, and probably, let's say, uh, the left the left leg, the left right has been burned, so we note that by a 1, which is equal to 9%, and the areas that have not been burned are equal to 0, which are denoted by 0, so they are not burned. So we use that formula. And then we said, once you know your variables, you can substitute them into the PACS formula to find the amount of fluids given in milliliters. So over the first 24 hours of care, so fluid is equal to 4, which is 4 milliliters. Of course, fluid is calculated in milliliters, and then the TBS times the TBSA, that is the total body surface area, and times the weight in kilograms. So you give 50% of the fluid in the first 8 hours and 50% of the fluid over the last 16 hours. So that is 100%, but it's bisected into two. Um, so our question is, when we go to our question, so our question requires us, it says that an adult patient has come into the burn unit during your shift. You take an inventory of the location of their burn in the chart below. The inventory is done on the person's body. That is where the inventory is done. So you can find the places that have been burned. So it says we have the part of the body, and then we have the band, which we say the 1 is equal to yes, that part has a band, and then the 0 is no, the part doesn't have a band. So we have our head, which is 1, the left arm, which is 0, the right arm, which is 0, the upper front torso, which is 0, the upper back torso, which is 0, the lower front torso, which is a 1, and then the lower back torso, which is a 1, and the upper left leg, which is a 0. Remember, the leg equate to 18%. It's not a 9. And then we have the right leg, which is a 0, the left leg, which is a 0, and the lower right leg, which is a 0. So those areas don't have fun. So then, given that their weight or mass is 48.7 kilograms, determine how much fluid they should receive per hour in the first 8 hours of their care. Remember, the 8 hours is 50% of their care. Answer to the nearest hundreds of a liter, 2 decimal places. So this is what we do. When you see such a question, the first thing that should come to your mind is to apply the Parkland formula. The Parkland formula is used to calculate the total fluid required in the first 24 hours after a burn. So the formula is the final volume in milliliters is equal to 4 milliliters um, times the TBSA, which is the total body surface area, times the body weight in kilograms. So the final volume, which is in milliliters, is equal to our 4. And then times, remember what we said, when we go back a little bit, we have 4 ones, and then the 4 ones, the head is equal to 9%, because we have a band, which is a yes, a 1, which is a yes. The right arm, which is a 9%, which has a band, is also a yes. The lower front torso also has a 1, which is a band, which is a yes, and that's 9%. The lower back but also which is a 9%, which is a 1, which is a yes. Let me show you what I'm trying to say. Where that is. So this is my question, and this is how I made it. Okay. So we when we add the ones, which are 9%, four nines, we get a 36, and then we multiply 4 milliliters, and then we multiply it by the total body weight, sorry, the kilograms that were given, which were 48.7. So our final volume in milliliters equal to 712.8 milliliters. And then they asked, so we calculate the fluid to be administered in the first 8 hours. Half of the calculated fluid is administered in the first 8 hours. So fluid in the first 8 hours is equal to the fluid volume that we got, which was 712.8 milliliters, and then we divide it by so when we divide it by 2 is equal to 3,506.4 milliliters, and then we calculate, remember half is a 2, so we divide it, it's divided by 2 because it's half the calculated volume. Usually we say there's a 50-50 on all sides. So we calculate the hourly fluid rate. To find the hourly fluid rate, we divide the fluid volume for the first 8 hours by 8. So we get the number that we got from the half, the 3,506.4 milliliters divided by 8. We are calculating the hourly, so is equal to 438.3 milliliters per hour. So then we convert to milliliters to liters. Remember, the question requires us to have our answer in liters. So since the answer needs to be in liters, we divide the ml by 1,000. Hourly rate, which is equal to 400, the hourly rate that we got, 438.3 milliliters over 1,000, which is equal to 0.4383 liters per hour. You can have a look at this. This is what I did. Yes. So we round it off. Remember, the answer wants us to round up to the nearest hundredths of a liter. So when we round it off, we come up with 0.44 liters per hour. Thank you so much. That is all I have to say about the Parkland's formula. Thank you.